I'm George Self. This video is one in a series designed to help with the R Labs for BASV316 Introductory Methods of Analysis. This is Lab 6, Visualizing Frequency. In an earlier lab, I showed you how to create frequency tables and crosstabs and other ways to display frequency. However, it's usually much easier to read a plot or a chart than try to read a table. And in this lab, I'll show you a lot of different ways to represent frequency using plots. One of the simplest methods is a bar plot. These are used very commonly in research reports, and I'm sure that you've seen them for a long time. R makes it fairly simple to create a bar plot. Here's a demonstration for a simple bar plot. Well, let me open this up and take a look at it. This is a simple bar plot that shows the Motor Trend cars database, the number of cars by gears. So with 3 gears, we have a lot of cars. With 4 gears, fewer cars, and with 5 gears, not so many. Our guided practice for bar plots, as usual, I'm going to go ahead and copy this and paste it in here. And our bar plot, we're going to use the stack loss data frame, and we want the variable for water.temp. The specifications require me to name this bar plot water temperature. The x-axis is labeled number, and the y-axis is labeled temperature. And I want 9 colors from the CM Colors palette. Let me run that. And there we have it. Now, since I know this works, I'm going to copy it. And let's go down to the activity, which is our deliverable for this activity. We're going to create a bar plot using the cafe data frame. And we're going to plot meal. The main title is going to be bar plot. Oops. The x-axis is labeled meal. The y-axis is labeled count. We're going to use the topo colors, and we want only 4 colors. And let me run this. And there we have it. All right. A clustered bar plot is where we're going to plot more than one vector on the same plot. Well, for example, here we have a data frame that shows the Titanic passengers, whether they survived or did not survive the Titanic disaster. You'll see we've clustered these by sex, male and female, and the count of the passengers. For our demonstration of the clustered bar plot, open this up for us. We're going to plot the cars by gears and cylinders. So cars with 3 gears mostly have 8 cylinders, and 4 gears mostly have just 4 cylinders, and so forth. Now, because I know this works, I'm going to copy this and come down here, paste it in here, and scroll up just a little bit so I can see what my requirements are. I want to use the invert data frame, spontaneous, and education. The title, and I'm just going to copy this because it's a little bit longer. Paste it right in here. The x-axis is going to be labeled education level. The y-axis is count. The color, 3 values from a custom palette using orange to white. So I'll change this to orange. And we want 3 values. That's already set properly. And the legend title is going to be spontaneous. And let me run that. And there we go. There's our nice orange chart. And as usual, because I know this works, I'm going to just copy it, because now we have our activity to submit for grade. In this case, I want the cafe data frame. And we're going to plot meal by sex. Scroll this down where we can see it a little better. The main title is going to be clustered bar plot. X-axis is going to be labeled sex. Y-axis is count. 4 values from a custom palette using dark green to white, and we need 4 values from here. And the title of the legend is meal. And run this, and there we go. And that's what we're after. A stacked bar plot is exactly like a cluster bar plot with one tiny difference. In a stacked bar plot, there is no line here that says beside equals true. Well, let me scroll up. For the cluster bar plot, you'll notice we have this line beside equals true. If you remove that line, leave everything else the same, you get a stacked bar plot. Let me run this and show you what a stacked bar plot looks like. Stacked bar plot just has, the number of cylinders, but this time they're stacked on top of each other instead of side by side. I'm going to copy this example because it's a nice example and paste it in here. I'm going to use the invert data frame. And for induced by education, I'm just going to copy this title. Education level and count. 3 values from a custom palette using purple to white. So let me do purple. And it's already set for 3 values. And the legend title is induced. Let me run that. And it looks like it worked. And there we go, nice purple chart. Let me copy this. And now the activity we need is to use the cafe data frame. Let me change that. We need the number of people who ate a given meal. So we need meal. and Cafe 6. Our main title here is going to be Stacked Bar Plot. The x-axis is labeled 6, y-axis is count. We want 4 values of a custom palette using goldenrod to white, and the legend title is going to be meal. And if I run this, there you have it. A nice gold chart. Next comes pie charts. Now I will tell you before I do anything else, pie charts are not often used in formal research reports. Most research scientists will tell you that pie charts are very difficult for users to read and interpret. You do often see them in public reports, in common reports in places like USA Today or Time, because people seem to like them, but they don't give you the same level of information for a formal research report that you can get from a bar chart or something else. However, R makes it easy to create a pie chart, so let's take a look at them. I'm just going to run this example. And here's a pie chart. It shows chick feed, and I'm going to do this kind of make it look pretty. Chick feed. And I will show you while we're looking at this, the reason we don't use pie charts so much, it's really hard to compare the sizes of the slices. We have 3 slices here, casein, sunflower, and soybean. Which of these is the largest? It's really hard to tell. And so pie charts are not often used for formal research. I'm going to copy this. And now our guided practice, let me paste that in. I'm going to use state.division data frame. Now state.division is a little odd. There aren't any vectors in this data frame, so I can just use state.division all by itself. There's no $ needed. Title is states by division. I need 9 colors from the topo colors palette and labels for each pie slice, and the labels will come from state.division. And let's run that and see what it looks like. And it looks like it worked all right. These are the states by division. You can see the various divisions and the number of states in each division. Well, since I know that worked, I'll copy this. And now for our activity. Using the cafe data frame. So I know I'm going to create a data frame from cafe. The number of people who ate a given meal, so that's meal, $meal, and cafe $. It's just meal, just one. And the main title is going to be pie chart. I want 6 colors from the terrain. Color palette and labels for each, and the labels will come from Cafe $meal. And let's run this, and there we go. And you can see the number of people who ate various meals. Next comes heat maps. Now heat maps are very interesting sorts of displays. They're very interesting to look at. The way that R creates heat maps is the lighter color represent larger numbers. So here's a heat map from Swiss Stats. For education, this lighter number means that this state And I'm not going to try to pronounce that because my French is not very good, but that state has the largest number of the highest education level. So a heat map is fairly complex to create. You can see our script here is fairly long. Let me run this. This uses the cafe data frame that we're pretty used to by now. And let me open this up. And this heat map shows the party size by meal. So I see here the lightest colors are here, so that most of our parties only had 2 people in there. However, for dinner, it looks like the most common party size was 4. And you'll see we don't have many parties at all up here in these 6, 7, and 8 size. So that's a nice little heat map. Let me copy this out and copy. Oh, I have another example of a heat map, and we can run this. These are judges' ratings, and the heat map is really fairly large. So let me squish it down here a little bit so you can see it. Judges' ratings, here are the judges' names, and then their various ratings here. Now there is a slight difference in these 2 demonstrations, and the reason I have 2 demos is to show you this difference. In the case of the cafe data, I am using only columns 8 and 4 to create the heat map. So in the data frame, if you look at columns 8 and 4, these columns would be the columns that give you party size and meal. However, in the judges' ratings, I'm using all columns, but now I'm restricting the number of rows to 20 to 1. So row 20 to row 1. In this guided practice, we only want the first 20 lines, so I'm going to use this example since that restricts the number of lines, but gives me all of the columns. Paste that in. Select the first 20 lines from the attitude data frame, and I even say here you should use something like this, so I'm just going to copy this and put that right in here and paste. That should give me the right number of lines. Title is Clerical Employees Attitude. X Lab is characteristic. Y-axis, I don't have a Y-axis label here, so I'll add that. Equals department. Be sure to put the comma after that. Row and column symbols are not applicable. We want to scale it by row, and margins of 8:3. That should do it. Let's see what we end up with. And let me pop that out. Take a look at this. Clerical Employees Attitude. Here's the attitude rating, or excuse me, department number, and here are the various ratings for the department. Our activity to submit is using the cafe data, and I see we're going to want only columns 3 and 4. So let me go back up to this example where we do have columns specified, and this is even the cafe data, so that'll make it kind of easy. I'll copy that, come down here and paste. Scroll up here a little bit so I can see the requirements. Heat map that compares the number of people dining at each meal for each day. And I say that the day is column 3 and the meal is column 4. But down here I've also given you exactly what you should put in, so I'm going to just copy that, and it goes right in here. Paste that in. Title is going to be heat map. Y-axis is meal. X-axis is going to be day. No row or column symbols. We're going to scale by column, and we want to set the margins to 8-7. And let's run that puppy. And here we go. And there we can see that our most popular meal is dinner on Saturday. And it looks like the least popular meal would be Sunday lunch and other. That's about it for heat maps. And finally, mosaic plots. Now, mosaic plot simply creates a mosaic where color is used to and size is used to indicate the values in the plot. For a demonstration, let me run this. And we can see here the gears versus cylinders. And I can see that the 4-gear cars with 4 cylinders is the most popular model. However, 8-cylinder cars with 3 gears is the next most popular model. Just looking at the sizes of these various rectangles. So, let me copy this out. And we will go down here and paste this in. We need a mosaic plot for induced and education vectors in the invert data frame. So I will do invert dot induced invert $education, and we're looking for a title of, and let me copy this so I don't make a typo on that, and paste it in here. The X label is number induced. Y label is education level, capital L. 5 colors from the terrain palette, and I need 5 colors. And run that baby. That seemed to work all right. And that's what it looks like. So let me copy this. Looks like I've got an error here. I'm not sure what I might have done. Terrain colors 5. Well, it seemed to work all right, so I'm going to ignore that error for now and paste that in there. To finish this up, we'll use the cafe data frame, and we want the meal by service. And the title for this plot is going to be mosaic plot meal on the x-axis and service on the y-axis. We want 5 colors from the terrain, AIN colors, and let's run. And that should be that. This has been a long video, and I know it's a long lab. However, once you get started on it, a lot of the pieces just kind of copy and paste together. Good luck with the lab. As always, contact me if you run into any roadblocks, and I'll be glad to help. I'll be seeing you online.